Hi, welcome to SciencloPodia. This is where I talk about science in everyday life. I dedicate this podcast to kids and their whole family to enjoy, and anyone who wants to listen from a kid's perspective. Enjoy! Hi everyone, I am very excited today because I'm going to be speaking with my friend Daniel, and he loves maths and he knows a lot about maths. He knows about pi, he knows cool functions in math. And I'm very excited because I'm going to be speaking something that he likes and I likes is pi and maths. So let's introduce Daniel. Hi Daniel.
Hi Rainer.
I'm very excited I'm going to be speaking with you because it's the first time I've ever had my friends, I think it's close to the first time I've had my friends speak on my podcast, and I'm just excited today. And today we're going to be talking about pi and math. So do you have any ideas why pi is important?
Pi is important because you can measure the circumference and the diameter of objects.
Why do you need that? I think it's my idea. I think you need that for bridges, because you know there's mud in the bridges, and after that there's rain and then it gets liquefied. You know that? I think we have to calculate some sort of friction. You know, that friction from the area. I think that's how they could use it. And pi is very important because pi is a constant between the circumference, the outline of a circle, and the diameter, the line in between, and it's touching. Imagine a circle, circle, and then there's the center, and then the diameter is actually a line intersecting the line, and the diameter can't be at the bottom of the circle. It has to be precisely in the center, and pi is the ratio between that, and it's approximately 3.14159. But Daniel, there's something that will amaze you. You know NASA that sent out rockets? You know that?
Yeah.
They actually used 5 digits of pi on a test experiment, and then they had 1 kilometer of error when they sent it to the moon. But they had used 8 digits of pi, 3 more, and then they had 12 centimeters of error. It's just 3 more digits. Isn't that amazing, Daniel?
Yeah, that is amazing.
Can you guess? Because once you told me how much digits of pi it takes to calculate the circumference of a universe.
I think it is 39 digits of pi to measure the circumference of the universe.
Why specifically 39? Is it because why do you use digits of pi to calculate the circumference of the universe? And why do you use pi for anything else? What else do you think pi would be used for?
I don't really know, but
I think it's a tough question actually. It's still a tough question actually, and I can't really think about it that much. But because pi, let me tell you the history of pi, and this is amazing. In ancient times, there were people called the Babylonians, and the Babylonians tried to find pi as a ratio between the circumference, it's my magic pen, a circle, and the diameter, a line. And they approximated it by putting a hexagon inside, and they found out that pi is circumference over diameter. You know that? Pi circumference over diameter, and then use a hexagon. Circumference over hexagon is so-called circumference. The perimeter of the hexagon was 6, and the diameter was 2. And then they found out that the pi was approximately close to 3. How do you think of that, Daniel? How close you think that was for ancient people to pi?
I think that was very close because ancient people didn't know lots of maths. I'm not sure if maths was invented then.
I think maths was invented then because why do you use
that's right.
6 and then they'll divide it by then? I think maths was invented before, and the Babylonians were actually ancient, and maths would have been more ancient. Isn't that amazing?
That is very amazing.
The math that we do today, like fraction, is actually ancient. I just can't believe it. It's just amazing. And next, who tried to estimate pi was actually Archimedes. You know Archimedes? He was a very, very famous inventor. You know, one of the inventions he made.
I don't know any inventions, but I know who he is.
One of the inventions was one of his inventions was actually ingenious. It was actually called the Archimedes screw. And then imagine if this was the sea, and then he would use the Archimedes screw, and then he would twist it, and water would come up without having them just go in the water. Isn't that amazing? And I've been thinking of making a water electricity generator, and I had to use that, and it's amazing. Daniel, since I know that you like pi, do you have anything that you'd like to say about pi? Like, do you have anything?
I know that.
Do you have anything? More is it hard to remember?
Yeah, I do have to say. I can't remember.
But that's the thing. When you know about pi is just like limitless. And do you want me to tell you why it's impossible? You know, people, they say pi is 22 divided by 7. That's actually wrong. Because 22 divided by 7
is
not equal to pi. Because pi is something called an irrational number. And irrational numbers, can you guess what irrational numbers are?
I don't know what they are, but I think they're like numbers with decimals. I think.
You're actually
sure.
Close. Irrational numbers are actually numbers that never end. They're decimals, and they never end. Like pi 3.1415. It keeps on going, and you can't represent it in a fraction because it keeps going on and on and on. You need a bigger fraction to do it. And Daniel, do you have any fun facts about pi? Because I got a lot of fun facts. Do you have any?
I know some fun facts that the Egyptians used pi to make the pyramids.
What? What? That's amazing. How did they use pi to make the pyramids? What did they do?
I don't know how they used it because scientists they found out that they use pi to make pyramids.
How did scientists discover it? How did they discover it?
They were just measuring how big the pyramids were, and then they just found out that it was the number pi.
What? So it's 3.1. But I can tell because
it was 3.14.
What? That's amazing. That actually amazed me because Egyptians actually thought pi as a fraction 220 something over 86, and then it wasn't actually pi, but then the pyramids was actually pi. That's just amazing. It's just mind-boggling, Daniel. Do you have any other fun facts?
I don't really have any other fun facts right now.
But I got another fun fact. Did you know that Archimedes Archimedes used the same technique as the Babylonians, but then he had it a bit more complicated than the Babylonians. This is how it was. So the Babylonians used a hexagon, and then one of the sides was equal to 1, but Archimedes used an octagon, and the sides was less than 1, and then he had something closer to pi, and he tried with more sided shapes, and the approximate number was 3.1418. That's so close to pi. Isn't that amazing, Daniel?
Yeah, that's amazing.
And also, Daniel, can I just tell you something?
Yeah?
Because do you know what pi is? Do you have any idea what pi is?
Pi is an infinite number which people people are trying to figure out, like, people are calculating pi each day, and the record for calculating pi is like 30 trillion something digits.
Yeah, it's 30 trillion digits, and 30 trillion digits is quite a lot. 30 trillion digits is like 30, I think it's like 32 trillion. 32 trillion is 32 million, and a million is a big number, and it's twice as that. And that, like, computers, it wasn't actually a normal computer, it's actually a supercomputer.
I know, because with a normal computer, it'll lag too much because it's very tricky to calculate pi.
Yeah, but there's lots of ways you can calculate pi. There's some by Newton, there's some by Euler, and there's lots of other ways. And also there's actually something called an infinite series of pi. So there's one where you can do like pi is approximately 2, square root of 2, and then next in a fraction over something, and then plus the square root of 2, the square root of 2 times the square root of 2, and then it keeps on going and going and going. So actually, Daniel, do you know any other people who actually calculated pi?
I don't know a lot of people. I don't know a lot of people who calculated pi. I only knew Archimedes, and like that's it, kind of.
So can you tell me more that you think could have calculated pi? Because pi is important, and there's very few people who have actually done it. In quite a lot of ways.
You can. Can I tell you something? That you can calculate pi by using a rope and drawing a circle.
Yeah, because once you showed me that you could get a circle. How do you do it?
So first I drew a circle, then I done a point which is the center. I drew a line across which is intercepting the center. Then I got a rope, put it around the circle, and then I cut off the rope when it touched the other end of the rope. And then I measured how much centimeters that rope is. And then I measured the diameter, and then I measured how much centimeters is the diameter, and then I done the circumference, which is the rope, divided by the diameter, and I got pi. It was 3.14159.
How close did you get to it? What was your answer that you got from your calculation with the circle?
I got 3.14159.
What? So actually, like, extremely close.
Yeah.
Yeah. And once I tried that, and then it didn't work. It said 3.06 something. So I think I have to do something with my technique. But I've never seen someone get a circle, and you can calculate pi with that. Well, actually, how important do you think maths is? Because
maths is very important because you have to use it for a lot of stuff. If you want to build rockets, you have to use maths. If you want to if you have to calculate something, you have to use maths.
Yeah.
For a lot of stuff.
And what else do you think maths could be used for? Like in things like computing stuff, like building stuff. Do you agree with some ideas from me? Like you could use maths for computer programs, like if you're trying to build a computer program, and you could build maths for making houses, because some architects need to use maths to check if the house is really stable. And math is everywhere. You can find angles everywhere.
Yeah, I agree with you. It's actually true that you have to use it for building, computing, and other stuff.
Actually, Daniel, what is math, and what was your first time that you done math, and when you get interested with it?
Math is math is like a subject, like not like literacy or like other subjects like that. And when I started maths, I was 3 years old, and I got interested in it when I was 4.
Okay. So what made you like it? Is there a specific thing, like addition?
It got kind of interesting after I learned a lot of stuff with it, and then I started liking it.
Because what part did you get interesting with it? What part did it actually make it the most interesting?
I actually don't really remember. I don't remember.
So it's basically just like me, because when I started maths, I just like everything. So what do you think of that when people actually want to do maths and then they actually don't know why they like it? Do you think they could actually be good at maths in the future?
I think they could if they like force themselves like enough to practice maths and then I think they could be good at maths later in the future.
Actually, Daniel, because we're talking about how they could be good mathematicians, how about dreams? What kind of dreams do you have right now, and what do you recommend for kids who want to be a mathematician? What do you think? What's your opinion?
I recommend for kids who want to be a mathematician to study a bit more maths, so you can learn more stuff. And
why is just maths essential to being a mathematician? Because you can't be a mathematician because you need to share ideas. I think you need literacy too.
Yeah.
And you agree with that because you can't write articles without literacy and you don't know how to present it. So actually, I think everything is important if you want to be a mathematician. Because if you're a mathematician and you're hunting down to find pi, you need to actually tell your story with English. You need to actually do lots of things that actually relate. So I think that everything is important for one dream. So Daniel, do you know some cool functions in maths? Because I know lots. What's your favorite one?
do you mean like addition or subtraction like that?
Or like signs, like the trigonometry, or squares or cubes. Well, what's your favorite one? And I'm gonna tell you what.
My ones are squared numbers and cube numbers.
Well, why do you like them? I think it's because sometimes I kind of like it at different points. It's because squared numbers and cube numbers are basically like multiplication. 14 squared is 14 times 14, and 14 cubed is 14 times 14 times 14. So is that correct? That you like the repeated multiplication?
Yeah, I do.
And also, my favorite functions. My favorite function is I have tons, and almost every single function is good. So Daniel, do you have any questions that you'd like to ask me, or do you have every question answered? And then we can...
Well, I have no questions about anything.
So actually, Daniel, how do you think maths could benefit the Earth? How could humans use math to improve the Earth?
I think I need to think about that. I don't really know right now.
How about like rockets? Do you think they could use that? Do you think they could use rockets?
Maybe. I'm not sure.
Daniel, I just remembered. I took some notes about easy ways to calculate approximately pi. And Daniel, to see if you know some of them. There's some way where there's a number called, let's call it n, and pick a random number, 5,000 to 10,000.
Can I do like 6,453 like that?
Okay, so I'm not actually going to do it, but this is how you do it. Get that number, and you can do it on a piece of paper, or you could ask a calculator to do it. Do your number, do n, is your number that you put like 600, 6,000 something. Multiply it by the sign of 180 divided by the number, then you get something approximately to pi, but it's approximately. And sometimes when I try to make it work, it glitched. You know the other thing, because can you guess? The square root of a number is almost equal to pi. What number is it?
I don't know. I think maybe like 3.
The square root of 9. Square root of 9 is actually 3, but that's not as close to the square root of 10. And the square root of 10 is about 3 point something something. And you find these ways amazing because they have weird ways, and using the weird ways, you can make something like a really cool constant like pi. And yeah, do you know any other constants like pi? Like it's number dot something something.
Do I know any infinite other numbers, like any other infinite numbers?
Yeah, like pi.
I know one number called tau. I'm not sure if a lot of people know about it.
Tau is actually pi times 2, and actually there's like pi's brother, which is basically called E or Euler's, and it's invented by Leonard Euler, and Euler is approximately, I didn't memorize it, 2.7 something. And then, you know Euler that I just said, do you know him? Can you explain who Euler is?
I don't know who he is, but I just knew the number tau and I didn't memorize it. I just knew it because I saw it somewhere.
Wait, you can actually know tau, you know column addition. Why can't you write all of the digits of pi you knew and then you added them up? Would that be okay?
Should I try that right now? Because but I don't want to do that because I know 100 digits. Yeah, I'm not doing that because I know 100 digits of pi.
Yeah, because like it's gonna be like basically 2 A4 pages. Daniel, Euler actually created something called the most beautiful maths equation. Do you know what that is? It's amazing.
No.
It's basically like this. E is approximately 2.71 to the power of I, which is imaginary, which can't be numbers, to the power I times pi. And then that would equal to -1. But then he done E times to the power of pi imaginary plus 1 equals 0. And people say it's the most beautiful one because it has 1, 0, exponent, which is another word for Euler's, and E, pi, and imaginary. And like, I just find it like amazing because 1 and 0 are basically the most smallest numbers possible, but actually you can count them. And do you know something else that has an equation with pi?
No, I don't really know anything else which has an equation with pi.
So actually, there's actually a lot of stuff that we talked about. And do you have any more questions? Because that's the end of it, because we talk quite a lot. And just before, how would it would you like to be in my podcast again if we could find another topic?
Yeah, I would like to be in your podcast again, but no, I don't have any more questions.
Okay, so Daniel, thank you for being on my podcast. I'm very excited to have been speaking with you, and you too, and I can guess that you probably are, and you mostly are. And Do you want to close simply by saying how much digits of pi you know? Just saying with pure digits of pi. Just saying it pure. Say it like 3.14.
Okay, I'm gonna try, but I'm not sure if I fully remember the 100 digits.
No.
I only remember like 80 something, I think.
Just try, Daniel, because you must always
Okay, I'm gonna try.
without the words in the song. It's up to you if you want the words.
Okay. 3.1415, 3.14159, 265,358, 79 and 323, 466 for 3, 38 and 32, 7,950 and 88 and 51, 9713939 and 51. 0589, 058, 209, 74, 94459, 23, 78, 164, 68. That's all what I know. That's all what I know.
Wow, do you want to give a round of applause to Daniel? I don't know 50, but I can speed it. But I think that's enough.
Awesome.
It's okay if I can speed it.
Yeah, it's okay. It's okay.
So actually you won't hear clearly, but I'm gonna learn more digits. I know 53, 3.14159265358379322345338419716939937510582. Is that correct? 582 is correct.
Yeah, that's correct.
Yeah, so it doesn't matter now, but we talked a lot and we've talked about pi a lot. So we've done our closing. So Daniel, would you like to say bye to me and let's have a nice talk together? And you had a nice talk. Bye, Daniel.
Bye, Rainer.
Thank you for being on my podcast. Bye. Thank you and see you.